Hello, physics friends. Welcome back. Today we're going to look at a conceptual problem and figure out how to attack it so that we can come up with the right answer. And so what I call this problem is which direction, if any, has a greater acceleration. So here's our situation. There's a block of mass m sitting on the bottom of a rough incline, and I know it's rough because it has a mu k of 0.3, and it's set up at an angle theta. And someone comes along and gives a push to the block. And so it's just an initial push. They do not hold on to the block as it goes up the incline. They just push it and let it go. So the block slides up the incline, turns around, and then comes back down the incline. So which direction? Up the incline? Down the incline? Or does up and down the incline have the same acceleration? Okay, well, how do we attack this? Well, what I'm going to do is I'm going to draw two free body diagrams. I'm going to draw one for the up direction, and I'm going to draw one for the down direction. Why am I doing that? I'm doing that so that I can look at the net forces acting on the box when it's going up the incline and when it's going down the incline. Because the net force is going to tell me how the acceleration is. The mass isn't going to change. Because remember, F net is equal to ma. So if this is a constant, the one with the larger F net, if any, is going to have a greater acceleration. Okay, cool. So here's my free body diagram for up the incline. Here's my box on its way up the incline. All right, I have hanging down, where are my markers? Here they are. All right, I have gravity pointing straight down, Fg. I have a normal force perpendicular to the surface, Fn. Okay. And then there's friction, and if this block is moving up the incline, which way is friction going to act? It's going to act down the incline. So I've got friction going down the incline. Force of friction. Okay. Now some of you might be saying, wait, where's that applied force? Well, let me ask you a really important question. Are you a Jedi? Because if you are, I would really like to know how you became one, because I would love to be a Jedi. We are not Jedi, unfortunately. Our midichlorian count not high enough. But what do I mean by that? I mean that I cannot apply a force onto this block unless my hand is on the block. And when I give an initial shove to something, my hand is not on the block when it's moving. And that's the part that I'm interested in. So there is no applied force on this block because my hand is not touching the block, and unfortunately, we are not Jedi. All right, so I still have components to the FGX. I have FGX and I have FGY, and then I can look at the net force equation. All right, okay, so F net equals ma. All right, so it's moving up the incline. Is there any helping force going up the incline? Any forces pointed in the direction arrow? No. So I have zero helping forces. But how many hindering forces do I have? I have a minus friction, and then I also have a minus FGX. And that's going to equal ma. Okay, cool. Now let's do the same thing, but for down the incline. So here's my incline again. Theta. Here's my box, and I'm drawing a down arrow because it's going to go down. I still have gravity, Fg. I have a normal force. I have friction, but if my box is going down the incline now, that means friction acts up the incline. So it changes direction. But what doesn't change direction is FGX. So I have FGY here, perpendicular to the surface, and I have FGX parallel to the surface. All right, now F net. Still helping minus hindering. And now that I'm going down the incline, I do have a helping force. I have FGX as the helping force. So this is FGX minus friction equals 0. I'm sorry, equals MA. Now, all right, which one of those is larger? Well, this is interesting. How am I supposed to figure that out? Well, this is a negative minus a negative, and this is a positive minus a negative. Okay, so if you don't really follow, a negative minus a negative is going to be a bigger number than a positive minus a negative. And I know that because this is like adding the opposite, and this is subtraction. Now, if you don't believe me, which is totally cool, maybe you need to see it or try it, that's cool. I'm kind of like that kind of person. I can just plug in some numbers. So if I say that FGX is 10 and friction is 5, this would be minus 5 minus 10 equals MA. And this would be 10 minus 5 equals MA. And let's say the mass is 1. Okay, so what's negative 5 minus 10? Well, I add the opposite, so negative 5 plus a negative 10, that's negative 15 equals the acceleration because the mass is 1. But over here I have 10 minus 5, which is 5 is equal to acceleration. Now, minus, negative, does that mean small? When I'm dealing with forces and vectors, negative does not indicate size. It is not size. Not size. It's direction. It's saying that the acceleration is pointed down the incline and that it has a magnitude of 15. This is the size. Now this is a plus 15, which tells me that the acceleration is pointed up the incline and that it has a magnitude of 5 or a size of 5. So just because it's a negative number doesn't mean it's small. It means a direction. So I look at the value, the absolute value, and it's going to be 15. So when I come back to this question, which direction, if any, has a greater acceleration? It's going to be when the box is moving up the incline. And the reason being is because there's more net force directed down the incline. Okay, so it's going to slow down going up the incline sooner than it's going to turn around and speed up. Right? That can be a tricky question. It's also a really good one for like a conceptual question, a multiple choice question, or one that requires a free response like on an AP exam. So I hope that helped explain it. When in doubt, like I say, always draw your free body diagrams and then you can write your FNet equations and figure out which is which. All right? Have a good one, guys.